What I like to do when I'm setting up in the yard in roughly the same spot every time is to mark it so that I could pretty much get the position exactly the same. So that polar alignment is a cinch. So check this out. Right here, although you can't see it, and over there, and under that leg are some divots I've placed there from the previous night. So that way, when I set up the next day, it's gonna be a cinch. I'm usually within about 10 to 30 arc minutes from the North Celestial Pole. And so I just do a quick truing up of the alignment, and then I'm off for the races, which is one of the things I do. Okay, so as you all know, I got my ASI1600 Pro with the USB 3.0, of course, 12 volt DC 3 amps power for the cooler, and the electronic filter wheel with a 7-position filter wheel. It's the HA-S203 and LRGB. And then of course my trusty guide scope and guide camera over there. But one thing that you guys wanna consider getting, this zip tie tells the tale that belies this story. Over here is a ribbon cable that goes to a dew heater strap that's underneath. So it's in between the camera and the filter wheel, squished in between there. And it essentially, its job is to keep the sensor window just a little bit warm so that no dew forms on it. And that has become an invaluable resource to me, and I'm so glad that I have that. So you have this like splitter. So this is for the dew heater strap, and then the other end goes into the power cable, sorry, the power port for the cooling feature of the camera. It's a great camera. I recommend you guys check it out. It's gonna revolutionize your astrophotography. All right, so you see how the laser is a little bit misaligned from those faint black lines of the target? Do not adjust the primary mirror first. The first thing you're gonna wanna do is adjust the secondary mirror using Bob's knobs. I'll post a link in the description. And you can see that the laser dot is right there in the center of that donut ring. Once you get that centered using Bob's knobs here, then you can adjust the primary mirror using these thumb screws. 1, 2, 3. And that's how we get our Newtonian reflector collimated. All right, let's see what we got here. That's just a test frame. Here comes the new one. Wait for it. Ah, that looks a lot better. Nice. I'm doing 7-minute subs. My guiding is great. I'm getting less than 0.3 of a pixel RMS. Taking for now about 2 hours of data in H alpha, and there's the fish head. All right. Okay, so I just learned something new. I could not get plate solve to work. I was trying to get the first of 2 align points going before I went to my target. I could not get plate solve to work with blind solve or near solve. And I wasted probably 10 or 15 precious minutes trying to get it to solve. My picture, my image, my test frame, the stars were perfect. No gradients. It was like the textbook example of a good image for plate solving with. Couldn't figure out what was going wrong until I went online, used an online plate solver at astrometry.net, and found that my declination was way off, even too far for blind solve to do for some reason. Once I got it all synced up, now everything's working great. Tip for the pros. You don't usually see this part of astrophotography, but once your rig is up and running and the data's coming in, you're checking on it and whatnot, but it really at this point is a waiting game. Sometimes you gotta just sit back, relax, and watch some Harry Potter. But what's cool, the way I have it set up is I'm doing both movie watching, relaxing, and I'm keeping an eye on my rig. Check it out. So we got the rig on the right, movie on the left. And that's how I do it.